of little f, we said? Capital F. And then it would be capital F of t. And then what would I do with my endpoints? Plug them in, good. So I would plug in capital F of x, capital F of a. Then what would I do with those two things once I plug them in? Remember your little rule, subtract. So it would be capital F of x minus capital F of a. Now,
everything's the same.
Okay, except for, I'm going to go back and write in, what are we going to take at the end? The derivative. Okay, now, when you take the derivative of capital F, which is the antiderivative of little f, what do you get? The derivative of the antiderivative is just back to f of x. Yeah? Now, what about capital F of a? Well, a is a constant, so if you take the derivative of a constant, what are you going to get? 0. It's going to go away. Okay, so when you take the derivative of a constant, the second part of that is just going to 0 out. So, here is your second fundamental theorem of calculus. We're going to just shorten it without all the crap in the middle. The integral of the derivative of the integral from a to x, f of t dt, is f of x. So essentially, when you take the derivative of an integral, all that's going to happen is you are going to replace the old letter with the new letter. So rather than this being in terms of t, now it's going to be in terms of x. Super, super easy. Okay, we'll do some free responses with it that make it a little bit harder, but this first page should be easy. Okay, so look at the first one. Now this is important. The bottom number for you to use that rule has to be a constant. Okay, now what constant does not matter, but it has to be just like a normal number. Okay, so look at number 1. I'm taking the derivative of an integral from a constant to x of t squared. Then it would be x squared. What's the only difference? I went from t's to x's. Other than that, exactly the same. So far, so good? Okay, next one. Okay, I have the derivative of an integral from a constant to x of negative 4 over t. What would it be? Negative 4 over x. Very good. Okay, I'm going to change this next one. I want it to be the derivative from x to 2 of y squared. So switch those letters to be backwards. Now, remember what I said. You have to have x on the top. So if it ever happens to be backwards like this, it is on your homework on a few of them, how do you switch the order back? You just put a negative in the front. Good. So if you need to change the order back, change order, apply a negative. And remember, that will always fix if it is backwards. So I would rewrite this as the derivative of 2 to x and put a negative to cancel out the fact that I switched it. And then that would still be a y squared dy. And then once your x is on the top, you just drop it in to where your other letter was. So if this was a y squared, now it's a negative x squared. Okay, then look at number 4. Is your order fine? Yep, so you would just drop that x in. You'd have 4 ln 2x. Now, notice there is not a plus c or anything on this, because when you take that derivative, it crosses out the c, which we kind of talked about. Okay? Alright, last example like that. Look at the bottom. Okay, you have an equation. It is f of x is the integral from 2 to x of your little square root thing. You want f of 2. Does that imply we need to take a derivative? F of 2. No, we're just plugging in, right? So I'm going to take my 2 and I'm going to plug it in where x is. Where is x? Not t. We're plugging in for x, so the top. Very good. So it would be the integral from 2 on bottom to where my x was is where I'm plugging in my 2 on top. And without me writing anything else, you should know the value of that. It's going to be 0. Why? Because these are the same. Okay, 3t squared plus 1 dt technically goes there. But remember, if you're going to integrate from 2 to 2, well, you never really integrated anything, because you started and stopped at the exact same number. Okay? Part B. Okay, now we want capital F prime. This is where your rule's going to come in. If I want f prime of x, that's going to be the derivative of the integral from 2 to x of 3t squared plus 1 dt. Because think about it, if f has an integral in it, then when I take the derivative, I have to take the derivative of that integral. That's where you use that rule that we talked about. So you would take your x, pop it in where the t is, and then have no more t. So it would be 3x squared plus 1 under the square root. Make sense? Okay, and then if I want capital F prime at 2, what would I do? Take my f prime of x and plug in 2. So that would be the square root of 3 times 2 squared plus 1. So this is f with an integral, f prime, the integral goes away. Then if you want to plug in a number, you would just do it.
Well, how did you get just the square root of 3x squared plus 1?
Because you had the derivative of the integral. And so remember, the derivative and the integral cross each other out, and all that you do is change the letter. So if this is an x, it's going to jump in where the t was, but the equation is going to stay the same. Because think about it, you do the antiderivative, but then you derivative it right back to what it was when it started. Okay? And then that'd be 4 times 3 is 12 plus 1 is 13. Okay? Good? Okay. We're not going to do our packet in order, which is going to annoy some of you. But we're going to do the third FRQ. So, go in your packet, skip, skip, and then this one. We're going to do this one first, okay? Because it's the easiest, and we want to start with easy, right? Okay. Look at your equation. So this is off of the AP test. So it says the graph of the function f shown above consists of 2 line segments. Let g be the function given by. Now look, this is a graph of f, and g has f in it, but f is inside an integral. So do you notice? You see, this is f. G has the integral of f in it. Okay? So the first thing that we're going to do in part A is find g of -1. Okay, now think about what we just did. I'm going to plug in -1 where x is. Where is x on the integral? The top. So I'm going to plug my -1 in right there. So it's going to be g of -1, I'm going to work it up here, is the integral from 0 on the bottom to x, which is now a -1, and then f of t dt. Now, how do you find an integral if you're looking at the graph of f? What would that be? Area. Very good. So we're going to shade from x equals 0 to x equals -1. That would be right here. What shape is that? Triangle. Okay, we can find the area of a triangle. 1/2 base times height. What's our base? Height? 3. So 3 times 1 is 3. Cut it in half, 3/2. What do you notice about the order that you integrated?
It's the opposites.
It's backwards. So what would I do to the sign on the 3/2? Negative. Okay, and I'm going to put a little star up here and put negative because backwards. Okay, remember that you are supposed to integrate from the smallest number on the bottom to the bigger number on the top. So if that's out of order, you just switch the sign. Okay. Next part asks you to find g prime at -1. Before you find g prime at -1, you need to find g prime of x. So I'm going to do that over here on this side. So g of x, this is like me showing my work, is the integral from 0 to x f of t dt. Everybody good with that so far? That's what was given to us down here. Okay, I'm going to take the derivative to find g prime. So g prime is the derivative of the integral from a constant to x of f of t dt. Well, we just did that rule, right? What happens when you take the derivative of the integral? The bottom number is a constant, the top number is the letter. What do you do with the letter? Whoop, plug it in. What is it now? F of x. And what is my graph of? F of x. So for g, I had to evaluate area. But if g prime is f of x, those are just the y values in my graph. So when they ask me to find g prime of negative 1, I'm going to put that over here. G prime of negative 1 is going to be f of negative 1. Because g prime and f are the same, because that integral kind of messed everything up. Okay, so look at your graph. What's f of negative 1? 0. Very good. Right there, that is 0. Okay, next we want to find g double prime at negative 1. So we need to find g double prime of x. Okay, well if I take the derivative of g prime, I'd get g double prime. What about if I took the derivative of f? What would I get? F prime of x. And what will f prime be if I'm looking at the graph of f? Slope. Very good. So if I have a question about g double prime, I need to look at the slope of my graph. Okay? So looking at negative 1, okay, that's a line. That means you can count the slope. Just count the rise over run. So from here to here, what's my rise? 3 over 1. So g double prime at negative 1 is 3 over 1, which is just 3. Okay? Does that make sense? Yeah? Okay. Alright, part B. Part B says, for what values of x in the open interval negative 2 to 2 is g increasing? Okay, well, g is going to be increasing when g prime is greater than 0, right? Now, is this a graph of g? No, this is a graph of f, but it can help us still answer the question. If I want g prime to be greater than 0, what is g prime in the graph of f? The y values. So if I want g prime to be greater than 0, I want f to be greater than 0. Where are my y values greater than 0? Negative 1 to positive 1. Very good. Okay, so what you're looking for is you want f of x to be above the x-axis. So the tricky thing that you have to remember is that they're asking you questions about f. I'm sorry, I said that wrong. They're asking you questions about g, but you don't have a picture of g. So you're having to use f to make those conclusions. Okay? So let's put our explain your reasoning because g prime of x, which is really f of x, is greater than 0. G prime of x, which is really just f of x, is greater than 0. Okay, part C. Where is the graph of g concave down? If I want to talk about concavity, am I looking at g, g prime, or g double prime for concavity? G double prime. What sign does it have to have? Okay, negative. But what is g double prime if I'm looking at f? G double prime is f prime, which is the slope. So where is your slope negative? On what interval? From 0 here till 2. So 0 to 2 because g double prime, which is f prime of x, is less than 0. And then what would be better, and I know this really annoyed y'all when we did it in the fall, but is I would put right here the slope of f prime. Okay, because there have been some years that they've been really picky about that, and then there have been other years that they've not cared. Okay, so I would just do it in order. G double prime, which is f prime, the slope of f is less than 0. Okay, part D asks us to sketch a graph of g on the closed interval. in order to do a sketch, I would do a first and second derivative test because I think it's easiest to do it if you do that. So set up G prime and G double prime. And I'm going to zoom out here for a second.
Slope of
F. Oh, that should be just the slope of F. Sorry. Cross that out. That should be F prime, the slope of F. Thank you, Helen. Okay, now, what is G prime really in my graph? G prime is the F of X. So when does F of X equal 0? Where are my critical numbers? Okay, -1 and +1. Put those on here. Those are my critical numbers. Okay, then what is my sign before -1 of my y values? Are my y values negative or positive? Negative. What about in the middle here? What are they? Positive. What about after 1? Negative. What does that tell us about G? G prime tells us if G is increasing or decreasing. So on the intervals where I have negative G primes, G would have been decreasing. What about on the section where G prime was positive? Increasing. Now remember, the other component to you drawing is concavity. What is G double prime in this picture? G double prime is the slope. When does the slope of the graph change sign? It's uphill slope till when? 0, then what? Downhill slope. So at 0, my slope changes from a positive slope to a negative slope. Now, what does that tell us about G if those are the signs of G double prime? That tells us whether it's concave up or concave down. What is it here? Concave up. What is it here? Concave down. And so once you do that, it's a lot easier to draw your picture. Okay, so set up your graph. -1 and 1. And I'm going to break my graph up into 4 parts. Okay, ready? This is the first part. Okay, that first chunk of my graph, it is decreasing and it is concave up. So draw a piece of a graph that is decreasing and concave up. It should look like that. Next chunk of my graph, here to here. What am I doing? Increasing or decreasing? Increasing how? Concave up. So that'd be like that. Okay, then at 0, I have to remark off my next section. So I'm going from 0 to 1. I'm still increasing, but what changed? Concave down. So you want to continue to be increasing, but this time now you're increasing concave down. And then for your last little chunk of your graph, what are we doing on that last chunk? Decreasing concave down. Make sense? And if you break your graph up into those little chunks, it's a lot easier to draw your picture. Now, let's double check our conclusions on parts B and C to make sure that we did it right. Okay, for part B, we said that our graph is going to be increasing from -1 to 1. Is that true here? Are we increasing -1 to 1? Yeah. Okay, C says I'm supposed to be concave down from 0 to 2. Am I concave down 0 to 2? Yes. Now, one other thing I want you to observe. What type of extrema is this at -1? A min or a max? Minimum. What type of extrema is this? Maximum. Look back up at your graph. And this is review. We've already covered this. But do you see why -1 is a minimum looking at your sign change? How does it change sign at -1? Negative to positive. That's consistent with a minimum. Y'all remember this? Okay, then over here at 1, how does my sign change? From positives to negatives. That's consistent with a plus to minus would make it a max. Make sense? Okay, let's go backwards one. Our goal today is to finish the first 3. So we're 1 down, 2 to go. Okay? Next one. Okay, we're doing the one with all the little triangles. Okay, I'm going to do A with you, you're going to do B. Okay? Part A, we want g of 6. Where am I plugging in 6 if this is my g of x right here? Where x is, where's x? It's the little top part, right? So I'm going to say g of 6 equals the integral from 2 to 6 f of t dt. Now on my graph, I'm shading from where to where? 2 to 6. So you should be starting here to there. What shape is that? You find the area of that? 1/2 base times height. What's my base? 4. What's my height? 4. 1/2, 4 times 4, what do we get? Okay, 4 times 4 is 8. Good. Okay? Next we want g prime of 6. This is where I would stop and do a little side work. So I'm going to write over here, g of x is the integral from 2 to x f of t dt. I'm going to find that by doing area, because it's an integral and I'm looking at f. That means area. Okay, g prime of x would be the derivative of that integral. Now you don't have to show your work if you see what you're going to do. If I take the derivative of this integral, what's going to happen? X is going to jump in. What's it going to be? F of x. If this is a graph of f, what is f of x? The y values. Okay, because remember, this is a graph of f. Okay, then let's go one more, because look, we're going to do g double prime in a minute. Okay, if g prime is f, then g double prime means I need to take the derivative over here. That'd be f prime of x. And what is f prime if you're looking at f? Slope. Very good. So let's finish out g prime of 6 and then g double prime of 6. Okay, how'd you get 0? Yeah, that's the y value. So that's f of 6, which is 0. You can label that again y value if you think that you're going to need it later. Okay, g double prime of 6, what is that going to be in terms of f? F prime, which is the slope. So f prime of 6, which is, okay, check your sign though. Rise over run would be down 4 over 2, which is negative 2. Good job. Okay, so this was the area. This was the y value. This was the slope.
Do we have to say f of 6?
I would, but I think you'd be okay if you didn't. Okay? Alright, can you do part B? Yes, you can. Okay, do part B. So you're finding g of negative 2, g of 2, and g double prime of negative 2. Anybody get an answer for the first one? Okay. So when I set up my integral, remember my 2 never changes. 2 to negative 2. You should have shaded, do a different color, we'll do pink. Okay, from 2 to negative 2 would have been this triangle right here. But it's above. Why would it be negative? Yep, it's backwards. Okay, even though that area is positive, it's negative because it's backwards. Very good. Okay, then what's your y value? 0. And what's your slope? 2. Very good. Okay? Alright, part C. We want to find our critical numbers for g of x. Remember that critical numbers for g of x are going to be when g prime of x equals 0 or undefined. Remember, that's what a critical number is. You would take the derivative, set it equal to 0. What is the derivative of g prime the same as, though? F of x. And so when does f of x equal 0? Yep, and there are a bunch of places here. I'm going to put dots on each one. Here's one, there's one, and there's one. Now, when I list them out, I'm going to list them separately because it's going to ask me to label them as a min, max, or neither. So, for my very first one here, all 4 of these are critical numbers. Is this first one a min, a max, or neither? Minimum is right, because if it was negative and then positive, it went negative slope, positive slope. That's a minimum. Okay, what about at 2? Neither. Why? Did it change sign? No, it went from plus to still plus. Remember, you're not looking at slope, you're looking at the y values. So that would be a neither. Okay, what about this one?
Would it be just neither, or would it be undefined?
You would just say neither. Okay, and then at 6 it would be a max. Very good. What about at 10? Neither. Okay. So let's go down here and answer the question. So our first critical number is x equals negative 2. Okay, and it is a relative minimum because g prime of x, which is f of x, changes from negative to positive. Do y'all remember writing these out in the fall, hopefully? Okay. What would we put for our maximum, which occurred at 6? Relative max, because, and then you'd put same crap, same crap, same crap, and then what here? Positive to negative. Okay, then what were my 2 neithers? Okay, 2 and 10, those are both neithers because same crap does not change sign. Okay? Alright, now those are relative mins and relative maxes. The next question asks you to find the absolute extrema. So the difference between relative and absolute is that absolute, you have to do a candidates chart. Candidacy table. Okay, so set up a chart for me. What goes in my chart? What numbers? Endpoints and critical numbers. Now, my endpoints here are wrong because I copy pasted this. What are the endpoints on your graph? Use your graph. Negative 4 till 12, okay? Those are going in my chart. And now for my critical numbers, which ones can I leave off? Which ones do we know are not going to win? 2 and 10. Those guys aren't going to win, so we're not going to put them in. So negative 2, 6. Now, 2 of these we already found. Remember, we want the mins and maxes for G. So what was G of negative 2? We already found it in part B. Negative 8. What was G of 6 in part A? Make sure you're finding regular G, not G prime. Regular G was 8. So this one and this one we already had done, and a lot of times they'll do that. So we only really have to find 2 more. Now I'm going to do G of 12 first. I'll do G of negative 4 second. Okay, G of 12. Remember, G has an integral in it. Where do I integrate from? What number? 2. So 2 to 12 f of t dt. Okay, let's look up at our graph. And let's count the area that we would have accumulated from 2 until 12. Okay, so I'm going to come up to my graph here for a second. So I'm starting the shading at 2. So I have 1 triangle, 2 triangles. What's going to happen with those? Why are they going to cancel out? One's plus, one's minus, and they're the exact same size. Okay, but I got to keep going to 12. If this whole area is 8, how big is that area? 4, because it's half of it. Now, what's the sign? Why negative? Because it's below. Or because your extra area, there's more area on bottom. That's fine. So these two guys cross out, and then I have 4 left over, but it's a negative 4. So that'd be negative 4 in your chart. Okay? Now let's find g of negative 4. That'd be the integral from 2 to negative 4, f of t dt. And then I'm going to come up and I'm going to shade from 2 all the way backwards to negative 4. Now, I already shaded from 2 back to negative 2, so I really only need to shade a tiny bit further. So here's 2, and I'm going all the way back to negative 4. What's going to cross out with these guys? If anything. Yeah, this half and this half can cross out, right? So where is my extra area that's left over? On top, and we know that it's still 4 because it's half. Okay, am I going to give it a positive 4? Why not? Okay, good. Even though this extra area is on top, because your endpoints are backwards, you're going to assign it a negative. Okay, because these endpoints are 2 to negative 4, that is backwards. Okay, so I would put a negative 4 here. Okay, what is my absolute maximum? 8. Absolute max is 8 at x equals 6. What is my absolute minimum? Negative 8, it occurs at? It occurs at where? Negative 2. Now, if negative 8 was not the smallest, if negative 4 was, can your absolute minimum happen more than once? Yes. Okay. Alright, part E, we want to know where points of inflection occur. Points of inflection are going to be when G double prime changes sign. When G double prime changes sign, what is G double prime looking at this graph? The slope of the graph. Very good. So look at your graph and I want you to put X's where the slope changes sign. Either from plus to minus or minus to plus. Just indicate X's on your graph where that happens. When your slope changes sign on your graph. How does my slope start off? Positive till when? Right there at 0. Then when does it change again? 2. Then when does it change? 4. Then? Not again until 8. Because remember, this whole chunk is a negative slope, right? Then it changes again there. So each of those x's are going to be your points of inflection. POI, POI, POI. Okay? So I'm going to list those x values out. I have 0, 2, 4, 8, and 10. Okay, so x equals 0, 2, 4, 8, and 10. Okay, then it says justify your answer because G double prime of x, which is f prime of x, the slope of f changes sign. Now remember, for a point of inflection, it does not matter which direction it changes sign, it just only has to change sign. And then part F we're just going to skip for now. Okay, we're not going to get to the first 3. We're not, that's okay. So tomorrow our goal will be to finish this and then we're going to learn the chain rule. Look at the top of your homework. Can I steal yours real quick? Okay, look at this sentence right here. Okay, any question that has a star on it, you have to know chain rule, which we're not doing till Wednesday. So I know you're probably very excited to do all your homework tonight, but if there's a star on it, you have to wait. Okay? Great. All right.